Do you ever wonder why you can't just dump anything down the sink? Or there are certain things that we can drink and eat and be just fine, and then we're told that if we drink other substances, we could get sick? Well, today we're going to explore what we call a precipitation reaction, where we mix two different liquids and observe the products that are formed, which is usually a cloudy liquid appearance. For this experiment, we're going to be using the following materials. We have a test tube rack that will be holding our test tubes. Our first substance is going to be potassium hydroxide, which is a colorless looking liquid. The second substance we'll be using is copper 2 chloride. Our next substance is cobalt 2 chloride, which has that red color. And then lastly, we're going to be using strontium chloride, which is a colorless liquid. Now, once we mix these different substances together, we will need to separate the contents of our new mixture. So we are going to be using filter paper. We've got a flask and our funnel to hold our filter paper. The first mixture we'll be observing is potassium hydroxide and copper 2 chloride together. So notice how potassium hydroxide has that colorless look to it and copper 2 chloride has that bluish color. So I'm going to start by getting a pipette full of our potassium hydroxide, and then I am going to get another pipette full of our copper 2 chloride. We are going to slowly put a few drops of our copper 2 chloride with the potassium hydroxide. Now notice how once they interact, there is a cloudish substance that appears. And now we've got two layers. The cloudy substance that you're seeing there is called a precipitate. And one of the products is what we call an insoluble solid, which means this cloud that you're seeing here is actually not going to dissolve in water. We're going to let this sit. The next interaction we're going to observe is potassium hydroxide and cobalt 2 chloride. We start by placing a pipette full of the potassium hydroxide, and then we're going to do the exact same thing with the cobalt 2 chloride and just place a few drops. Notice you have this cloudy formation that looks like a light pink color. The last interaction we're going to observe is when we mix potassium hydroxide and strontium chloride. Notice how both substances are colorless in appearance. So let's see what happens when we mix the two together. We're going to get a pipette full of potassium hydroxide and a pipette full of our strontium chloride. Place a few drops. Notice how once the two are interacting, there is a white substance that forms. The white substance that you're seeing here is actually strontium hydroxide. All three substances had this potassium hydroxide. Now notice how this substance was reacted with three different substances, and notice the different products that were formed, including the different colors. To take this a step further and to allow us to see what the substance will look like when it's separated from the mixture, obtain filter paper. We're gonna fold this filter paper into fourths, open it up into a cone, and allow it to sit right above our funnel. I'm going to pour this entire mixture through my filter paper, and then we wait. We're basically allowing the liquid in this mixture to be filtered out as the filtrate, and then we will see that precipitate left behind on our filter paper. So this is actually the copper 2 hydroxide that has formed from this mixture. If I were to filter this mixture out, what you will see left behind is this type of powdery substance from this mixture right here. This is cobalt 2 hydroxide. So if I were to filter this mixture, we will see that this purple solid substance is going to be our precipitate. We did just pour out our strontium chloride and potassium hydroxide mixture into this filter, and so we are just waiting for it to filter out. But if you notice, you'll see that we already have some of our filtrate coming out of that mixture. That's that liquid from the mixture, allowing the rest of the solid to stay in our filter paper. And so if you look closely, you'll see that there is some of that white powder. So you are seeing three different types of precipitates that are formed when you react three different substances with potassium hydroxide.
Hey guys, for our experiments today, we're going to freeze water in time.
So today we have a speaker attached to a computer that is set up such that we can program in a specific frequency for the oscillation of the speaker. We have water on standby and this funnel and flimsy pipe.
So the reason that you can see the water like this is because the speaker is oscillating at 30 hertz. This is an example of an optical illusion perpetrated by our cameras. Believe it or not, if you're ever on a helicopter or you're on an airplane and you're looking at the propellers are moving at a certain weight that causes them to bend in the camera. That's because the camera is moving at a frame rate. Normal cameras run at 24 frames per second. For our optical illusion today, we have set our camera to 30 frames per second. And we have our speaker oscillating at 30 hertz. And if you know anything about sound waves, it's just a wave. So you can have 30 waves in a second, causing our water to look like it's standing still. I hope you guys enjoyed that experiment today. I hope you guys learned something. Be sure to follow for more awesome experiments from Expulsion Science.